art and illustration?
Well, those who've seen me do things before, and this was over a year ago, will know that more often than not, when I do a presentation, some maths appears in it and everyone freaks out. So I decided to do something that's a bit easier on the brain tonight and talk a little bit about some space art and illustration. Now, of course, it is an incomplete survey because there's so much of it out there. And at the end, why didn't he cover insert name here? Unfortunately, this is one of the problems with this, but we'll do a bit anyway. Well, let's start with this. Now, before I come to this very thing, of course, the earliest depictions of objects in space were lunar calendars carved into bone in the Stone Age, dating back about 30,000 years. But this shield-like object, about a foot across in old units, is alleged to have dated from the Bronze Age, but we don't really know where it actually came from. It appeared in Germany, having been looted from somewhere, and eventually the police picked it up. If it is Bronze Age, that makes it pretty old, but it might be later than that. It might be Iron Age. And what you see on this disc are what look like representations of the sun and the moon and stars. Or at least that's what you think it means. I don't think there's any doubt about the crescent-shaped moon symbol on the right, but the other things could be anything, couldn't they, really?
Well, I mean, you've got that cluster of 7 there, which could be the Pleiades.
Yeah, it might be, yeah. And in fact, actually, that's an interesting point, because I'm going to show you some other things where you see little clusters of stars. Diagrams. The Greeks were very good at measuring things, and in fact, actually, of course, they knew that the Earth was a sphere, not flat. In fact, of course, one of the ways in which they measured the distance to the moon was to look at the Earth's curved shadow falling onto the moon, and did some geometry. The picture at the top there shows you that, and I won't go into details here because I do have a little bit of a talk about how that was done, which I'm going to save up. But that picture actually came from the Vatican Library, and it's actually a 10th century transcription of the original Greek version. But underneath there's a rather simpler diagram that shows you how, in fact, they measured the distance to the sun. They figured that if you could measure the angle subtended between the moon when it's at its first quarter and the sun, you have a right angle triangle, and you can measure that very slender angle of the triangle. You could then determine the distance to the sun. And it almost worked, except the angle's so tiny it was almost impossible to measure it with the technology at the time. But nonetheless, they got Aristarchus got using this method a sort of distance to the sun in millions of miles, which is pretty impressive. These are Chinese star charts from the 7th century, and yes, you can see star clusters represented in these diagrams, although they're rather diagrammatic. These sort of strange circles and squares and zigzaggy formations may not be real things, but you can't fail to notice top right there that they've got part of the constellation of Orion quite clearly marked, and above it I suspect that the object above it near the top of the diagram is in fact Auriga, the charioteer. So these are early representations of stars, early star charts if you like, although they're only partially accurate, as you can see, and partially fanciful. Of course, also you see a lot of these things dating back centuries, diagrams representing what they believe the solar system to be like. Obviously, these are all geocentric models with the Earth at the center, and the planets and the sun represented in traveling around the Earth. But basically, of course, we now know, of course, that the Earth is not at the center of the solar system, but nonetheless, to them, it did seem that that was an explanation for what they were observing. Comets appear in ancient pictures and indeed this embroidery or tapestry, as it's often referred to. On the left there, you've got the Bayer tapestry with Halley's Comet, which came round in early 1066. Of course, comets in Europe were regarded as a portent of doom or evil, which was certainly the case for Harold II, but not so much for William of Normandy. So it doesn't quite work in that respect. And then on the right here, we've got Giotto's Adoration of the Magi, which was painted at the beginning of the 14th century. And again, you see a comet in the background, which is believed again to be Halley's Comet. Now, sometimes you see pictures which are said to be medieval, but are not. This is one example. This is actually from a 19th century book. And the picture is called Atmosphere. We don't know the artist who produced this illustration, but the author of the book, Camille Flammarion, actually wrote a book on the atmosphere, as you can see there, popular meteorology. It's not medieval, but it may, and indeed the book may have had an influence on Van Gogh, as we'll see in due course. But certainly the picture looks like it might have done. Now, we saw Chinese star charts earlier, but the first really accurate ones appeared at the turn of the 16th and 17th century. This is Johann Bayer's uranometria. A geometria is measuring the Earth. Uranometria is measuring the skies, which is what you see here. And one of the illustrations from that work is shown on the right there. That's Orion. And they really are absolutely beautiful, aren't they? They're produced with copper plate engravings and printed onto paper. And you can see two more here. That's Aquila on the left there, the eagle. Seems to have snatched a small child. And that's Cetus on the right there. So there were, in fact, in this work, something like about, I think, 51 star charts in all. 48 show the standard constellations that we're familiar with. And there are extra pages which showed new ones that had been recently discovered by Europeans voyaging into the southern hemisphere. Well, it's not just that we illustrate things in space, but obviously illustrate people looking at it. And on the left there, you've got a 18th century engraving showing a German astronomer using a transit telescope. Basically, if you look, it rotates in one axis only, and you wait for objects to pass in front of it rather than steer your telescope sideways towards them. And it's used for measuring the positions of stars in the sky in terms of when they pass through the field of the telescope and the angle they make with the horizontal. And that's basically what that's for. It does look, by the way, as if he hasn't finished the telescope. There's an awful lot of spare parts lying on the floor. But anyway, there we are. And on the right here, you have Joshua Reynolds and family. And this is a classic illustration of the Enlightened period, showing the family here with globes, books, and a telescope, showing that, and indeed a picture, a map rather, at the back there, showing how people were beginning to gather knowledge in a more systematic way than they had previously. By the way, that telescope that's sat on the table there is a sort of Cassegrainian style design with an open aperture at the front. The light travels down the tube, hits this concave mirror at the bottom, goes back to the top, hits a convex mirror held at the front, and then back down the tube again to the eyepiece at the back.
Wow.
And here's some more illustrations from works of the period. You can see here on the left there, pictures showing how the seasons occur, how eclipses occur. On the left there, you've got a solar eclipse, and on the right, there's a picture of how a lunar eclipse occurs. And then on the right-hand side here, you can see a book that's literally just covered in illustrations of equipment and astronomical objects of one sort or another, including an illustration of the moon. You can see halfway down the left-hand page there, and you can make out a crater at the top of the moon, which is Tycho, the crater. And what you're seeing there is obviously it's at the top of the picture, because of course with a conventional telescope at the period, the images would be upside down.
Yeah.
A lot of astronomical books were printed with pictures of the moon and the planets upside down until relatively recently. Well, this is an interesting fellow. He's from the early 19th century, Caspar David Friedrich, and he was a German romantic landscape painter, generally considered the most important German artist of his generation, in fact. He's best known for his allegorical landscapes, which typically feature contemplative figures silhouetted against night skies. Well, you can see that sort of thing here in these pictures here. On the right, you have a figure sat next to what looks like a dolmen, a Stone Age grave. And on the left there, a couple of figures looking from a forested view towards the sky. And of course, like most artists, Friedrich often produced some multiple versions of his work. And in fact, actually, if we look at the next slide, you can see, oh, sorry, I've jumped past. I was going to say, he actually produced several versions of the left-hand picture there. This one shows a man and a woman, but there's also versions with two men. But what's interesting about these is, from the astronomer's point of view, is what's in the sky. And if we look at that more closely, you can see what it is. It's an early moon, if you like, a crescent moon, and you can see a very bright dot next to it, which is almost certainly Venus. And also you can see with the moon, you can see the effect of earth shine, light reflecting off the earth onto the back of the moon, onto the dark side of it, which reveals the entire disk of the moon. Now, these are really quite striking images, I think, and quite interesting. And the thing is that we do see that sort of thing. On the left-hand side of this slide here, you can see a genuine example of the moon and Venus, which I took early one morning. Admittedly, this is a moon that's very almost at the end of its cycle rather than the beginning, but you get the idea. And what about flags? Well, if you look at these two flags on the right, they do have a striking resemblance to Friedrich's paintings and indeed my photograph. Well, the stars are five-pointed because they represent the five pillars of Islam, and indeed the origin of this star and crescent design dates back to the Ottoman Empire, in fact. But nonetheless, it's almost inescapable that this is an illustration of the moon and Venus as they would look in the night sky, up to a point anyway. Of course, the moon often features on mosques. On the minaret, you often see on the top an illustration of the moon. And although I haven't got a definitive sample to show you here, you often find that the angle of the moon as represented does indicate something about the latitude in which the mosque was built. At temperate latitudes, the moon generally looks like it does on the left. And if you're on the equator, it often looks something like the picture on the right there, setting vertically downwards.
Wow.
Anyway, astronomers and other people are often represented in cartoons. You can see here on the left, Mr. Babinet's been told there's a comet and he's looking in the wrong direction. And therein lies one of the problems with astronomy. If your telescope's not pointing in the right direction, you might miss something, which is why we have these synoptic survey telescopes now with short focal lengths and wide angle view so that they don't miss anything. But obviously the traditional telescope with its narrow field of view, in a sense like looking through a rolled up newspaper, unfortunately means you might miss something. And on the right here we have a political cartoon, in fact. And what you see in the picture there is a comet, and the comet is Napoleon. And Napoleon is flying towards the sun, which is represented by George III. And you can see John Ball is looking at the two with his telescope. And it says, aye, Master Comet, you may attempt your periheliums or your devilish heliums for all I care. But take the word of an old man, you'll never reach the sun, depend upon it. Anyway, there we are.
Lovely.
And of course, we still have cartoons about astronomers, as you can see on the left there, getting an all-round field of view. Please don't do this. And then on the right there, well, it's kind of rude, but it's quite funny as well. And of course, Larson. We all know that Larson does lots of science fiction, fact-based cartoons, like the one on the left with the aliens there. And of course, the rocket scientists. Everyone knows this one, this crooked rocket. We're not exactly rocket scientists. Well, believe it or not, some amateur rocket makers built one, which you see on the right there, and they launched it. I think it's fair to point out that if you look carefully at it, you'll notice that the tail fins are actually far more, sort of sensibly placed than on the original Larson cartoon. There we are, folks. Now, of course, Jules Verne, as we all know, wrote From the Earth to the Moon, a wonderful science fiction novel, and it was copiously illustrated. And you can see a couple of pictures from it. On the left there, you can see the capsule halfway to the moon. And if you're wondering what that object is on the right of the capsule, it is in fact a dog. They've obviously let the dog out for a wee. And it clearly, in Jules Verne's universe, dogs can survive in a vacuum. So it didn't seem to suffer any other effects. And similarly, when they're on the moon, as you can see, no one's wearing a spacesuit, and I must have wondered how they got back, since their capsule is completely buried in the rocks, as you can see on the picture on the right there. But anyway, there we have it. What's kind of interesting, it is pure coincidence, is that the capsule depicted in the Jules Verne story has almost the same dimensions as the Apollo command and service module that was sent to the moon in the missions from the 60s and 70s. Well, we all know about Van Gogh, and of course, his Starry Night illustration, we can see on the left there. It's one of his most famous pictures, but probably it doesn't depict anything that's actually, it's not a direct copy of what he saw. It's more fanciful than that. And it's hard to make out what the object on the right is meant to be. It could be the moon, it could be the sun. It could be just Venus. We don't really know. But on the right there is another of his paintings, which is far more approachable from an astronomer's point of view. This is a view over the Rhone River and looking due north. And if you look, you can see upper middle of the picture quite clearly the asterism of the plough or Big Dipper. There it is. You can't miss it. And indeed, the star that's on its own over on the left-hand side is probably Arcturus. He did paint pictures where not just... I've just been informed that it is the crescent moon in the Starry Night picture. Anyway, there we have it. But you can see the plough on the right picture there. Moving on. Into the 20th century, of course, science fiction took off in a big way in the 1920s and 30s. And of course, in the 50s and 60s, those of us who are old enough to remember, there was the Eagle comic, which was young boys reading, and of course depicted the wonderful Dan Dare, who was a space pilot. and of course his nemesis, the evil Mekon on the left there, who some people feel bears more than a slight resemblance to Dominic Cummings.
That's a starship on the left, isn't it? On the right there, isn't it?
Yeah. Sadly, though, the illustrator, whose name I'm afraid has slipped my mind, he left the Eagle comic as an illustrator towards the end of his career, and essentially, like most people, I know Friedrich no exception, died more or less penniless.
Oh dear. Classic.
We have to move on to science fiction movies. These aren't, of course, art as such, but they are examples of what was around in the 50s. The one on the right is more of an eco-warrior style movie, warning us of the folly of our behaviour. But more typical of the period is the one on the left, The Invasion of the Body Snatchers. These movies came out in the era of the McCarthyite persecutions in America, where the Reds under the bed thing, that the communists were infiltrating all levels of society behind our backs. And of course, for aliens in these movies, you could read communists effectively. But the thing is, of course, movies like this need posters to advertise them. And again, we come across art and illustration. And here's a few examples. Mon from the late 1920s, Fritz Lang film. Interesting, by the way, because I read somewhere that Frau Mond depicts the launch of the rocket with a countdown with 10, 9, 8, 7, and the launch. And it was the first ever time that had been done, long before anyone did it in real life. Moving on, of course, 2001 Space Odyssey. Everyone knows this film, which I remember seeing in the late 1960s, a really remarkable piece of work. You might be interested to know, by the way, that the spacecraft illustrating it were modelled from timber. They were actually carved out of wood, believe it or not, and painted up. Or at least some of them were. And in fact, actually, I did work briefly in the special effects industry, making spacey things, before, of course, the computers took over. It was a job I had for a relatively short period. I worked on stuff for the Moonraker film, the James Bond film, and also when I left, we were just in the process of producing a new R2-D2 for the second Star Wars film, because the R2-D2 robot in the first film was made from surplus parts from an Air Caravel airliner and was apparently pretty heavy and hard to move around in. And Kenny Baker, the chap that was inside it, was struggling a bit. So a lightweight copy was needed.
And then we have the 2001 A Space Odyssey painting there.
Yes.
I have a T-shirt with exactly that design on it.
Oh, right. Okay. Yeah. Fantastic.
Yeah.
And of course, Alien, a Japanese version of the poster. I like Alien for one reason, and that is that the spacecraft do actually obey Newtonian physics. Unlike both of them, they certainly don't in Star Wars, as everyone knows, but they did in Alien. The only problem is Alien, in a way, to me, illustrates one of the problems with the science fiction movie industry. Is it is heavily conflated with horror. Whereas if you read science fiction books, there are not that many horror books, but they usually are when they're on film. And then, of course, we have Dune, which came out relatively recently. I'm waiting for the second part of that to emerge.
March the 1st.
Yeah, I gather it's delayed, isn't it?
Yeah, well, it was delayed. It was due out the end of last year, but they've delayed it to March the 1st.
Oh, good. Well, I know it's coming. Fantastic. And then, of course, a couple of movies which, again, here's the illustrations that went with them. And these are both pretty intelligent films. Arrival, in which, as you know, translators are trying to figure out what aliens are trying to say to them. And then on the right, Contact. Well, not surprising it was intelligent, because Carl Sagan essentially wrote the book on which the script is based. It does contain an interesting twist about it, because Jodie Foster the scientist, is skeptical of the religious views of her boyfriend, who stood behind her in the picture there, and says that science requires proof. But when she takes her journey into space, courtesy of some aliens, there's no evidence when she gets back. And forced onto the back foot in front of a congressional committee, saying, well, I really did go there, honestly. And they say, well, we got no evidence for it.
There is a shred of truth in the movie, and that is that there's a period of time roughly equivalent to the time that she would have spent missing on the tape.
Yes, nearly at the end, isn't it?
Yes.
One of the politicians, I think it was the Secretary of State, I can't remember. She said, "There's nothing on the tape, but there's 48 hours of nothing on the tape." If I remember right, or something like that. Anyway, yeah, you're absolutely right.
And it was a damn good book too. Really enjoyed that book.
Yeah. Moving on, of course, we have to talk about this man. By the way, I don't know how to pronounce his name, whether it's Bonestel or Bonestel, but does anyone know?
I think it's Bonestel, Keith.
Thank you. Yeah, well, he's one of the most copious and the most recognizable of 20th century illustrators of things in space, and did a lot of his work before the first spacecraft ever went into space. We see here on the left the surface of Mercury, which he painted in 1948. You can see some tiny astronauts, often dwarfed by the landscape in most of his pictures. You can see the bottom left of the Mercury picture. If you're wondering why the sun looks a bit comet-like, it's because they've illustrated the dust that exists in the plane of the solar system, the zodiacal light, as it's called, in this picture. And on the right here, we have a picture of Mars viewed from Phobos. Again, there are some astronauts in the picture. Really fantastic when you consider when they were actually produced. And so I'm sorry, there's something on top of something else here, so I'm going to skip on. But Bonestel did paint pictures of the surface of Mars, sometimes with canals, sometimes as an arid desert, which of course it turned out to be. But I thought I'd show you this illustration by a chap called Morel. This is from a 1930s encyclopedia. And you can see here how carried away people were with the Martian Canal thing in this picture here. But there is something true about this picture. You see a polar sea. And in fact, we now know that at some time in the past, Mars indeed did have a polar ocean. There's a low, fairly relatively flat expanse near the North Pole of Mars with marginal features around it suggest that there was water there at some time. But canals, no. They were a figment of people's imagination. Here's Bonestel's pictures of Saturn from Titan and from Mimas. You can see here, I mean, if you look at the right-hand one first, this remarkable image showing the shadow of the rings cast onto Saturn's surface, something that you don't see from Earth, but you could infer if you thought about it three-dimensionally. And you can see a spot on the surface of Saturn there, which is the shadow of one of the other moons of Saturn cast onto the cloud decks of the planet there. And again, tiny astronauts you see in the foreground. And on the left there, this picture of Saturn from Titan, well, the sky isn't right, of course, because we now know that Titan's shrouded in an orange smog, but nonetheless, it is a remarkable illustration because, amongst other things, if you look at the left-hand side of Saturn, you can see how the sunlight reflecting off the rings is cast onto the cloud decks of the planet on its dark side. He's thought of all of these things. I think that's amazing, really.
It is. Well, yeah.
And here we have pictures of Bonestel's of the moon. They look very much like the real thing. They really do. If you've seen pictures taken by the Lunar Reconnaissance Orbiter, you'll know that looks pretty similar. By the way, my lights in my room just flashed a bit, so don't be surprised if I disappear in a minute due to a power cut. And here I've put alongside it Mary McIntyre's picture of the middle of the crater Tycho, and she's copied that. Well, copy is not the right word, but she's used one of the LRO images to produce her work, and you can see how similar this illustration produced in the Space Age looks to Bonestell's picture, which he painted well before the Space Age started. It shows how good he was.
It shows how good Mary is as well.
It does, doesn't it? Yes, indeed. Absolutely. He depicted spaceships in his pictures. In 48, we have the sort of streamlined V2 shaped spacecraft, which wouldn't be needed to go to the moon as such, unless you went through the atmosphere first of the Earth. And on the right, probably a more realistic depiction of a lunar landing spacecraft, which in space do not need to be streamlined in any way and can be designed in fairly skeletal fashion, as you see in this picture on the right. And he also produced sort of informatics, illustrations to educate. And you see on the left there some subsurface habitation modules on the moon. There are these lava tubes on the moon, which you can burrow down inside. And the advantage of putting your modules down there is, of course, you're shielded from the sun's radiation and cosmic radiation in general, which is a good idea if you don't want to develop cancer. On the right here, we have biodomes with plants growing in them. You can see, and in the distance there, a telescope, which of course on the moon would work beautifully without an atmosphere to spoil things. It does, however, look a bit like a telescope that you would look through the back of, which wouldn't be a very practical thing to do on the moon. You would wire it up with a camera. That would be the sensible thing. Thinking of those biodomes, of course, well, no, I'll leave that. But Bonestell also did illustrations of other things. You can see their buildings, bridges. You know, he was pretty prolific illustrator and artist, and produced a few film posters, as you can see on the top right there. And there's another one of his lunar illustrations at the bottom. Fantastic, really, really fantastic. And he even ventured out into interstellar space and depicted planetary views from exoplanets orbiting other stars. On the right-hand side there, you have a planet that is orbiting a rapidly rotating star, which has, as a result of it, turned into an oblate spheroid. In fact, the star Altair in Aquila is probably this shape, we think. In fact, actually, using optical interferometers, we now know it really is that shape, shaped like an M&M.
Right.
The other pictures show, binary stars, and of course the effect they would have, you get double shadows. You see, if you look on the left-hand picture there, you can see twin shadows produced by the two stars. By the way, he's marked in an orbit for one of them, which of course you wouldn't see, but you get the idea. And of course, imitations of a serious form of flattery, and of course, binary star planets. Well, there we go. There's one in Star Wars, Tatooine, or Tunisia in real life.
We've only known somewhat recently that planets can maintain stable orbits around a binary star system. So that's
true. Yeah, that is true. Yeah. We have found a few now, haven't we? A few of the Kepler objects, I believe, are such things.
Perhaps that wasn't an orbit he was depicting inaccurately. Perhaps it was meant to be a ring around the planet.
Well, here's the thing, right? There's something interesting about that. It could be a ring around the planet, but it's a very oblate spheroid planet, as you can see, suggesting it's either a planet spinning extremely quickly or it's a stellar object. By the way, this picture is not distorted. They really are flattened in the original picture. I don't know is the answer, really. But one thing did occur to me. If it's meant to illustrate an orbit, and I don't know now, because you can actually see a line running in front of that object, can't you?
Yeah.
the white object's got a line in front of it. So you may be right. Maybe you're meant to be a ring. I don't know. So it's hard to say, isn't it? But
Yeah, it is.
yeah. Anyway, but if it was an orbital pattern, then that star would actually plunge through the atmosphere of the other star.
Yeah.
And we do know of examples of that in real life. There are examples. There's one binary pair where one star is permanently ploughing around inside the upper atmosphere of the other one.
Yeah, that's right. Yeah.
So it's quite an extraordinary thing, really. Anyway, I'll skip on. And, well, here's an artist who really did go into space, Alan Bean, who was on the Apollo 12 mission. Produced images, paintings, I should say, of astronauts on the moon. And one of his distinctive trademarks was the textured surfaces of his paintings had boot prints on them, as you can see from the lunar astronauts' boots. And they're really quite remarkable in appearance, really. Unfortunately, Alan died about 6 years ago. And indeed, we're running out of Apollo astronauts now, but not many of them are left. Which just goes to show how tardy we have been in going back to the moon, doesn't it, really? These pictures illustrate the sort of thing that he did. And in fact, there's some more of his pictures here. Here you see one astronaut pulling another one up. Falling over was something that happened quite a lot on the moon, as if you watch the footage. But with 1/6 gravity, it was not likely to cause serious harm. And these pictures here on the right, we have the Apollo 13 problem with the service module illustrated here. And of course, as you know, the one of the fuel cell tanks exploded, and you can see the fragments are surrounding the spaceship. And what most people don't think of when they're on Earth is they think of fragments flying off something and then falling behind. But with no drag in space, the fragments just sail along with you. So a permanent cloud of debris that goes with you everywhere you go, which to some extent he has illustrated in this picture.
Yeah.
On the left there, he's it's a bit of a self-portrait for him because he's one of the astronauts in the picture there. Apollo 12 landed very close to an unmanned space probe called Surveyor 3, and the two astronauts went to have a look at it. And I think they cut the camera off, if I remember right, and brought it back. I have some recollection of that.
Yeah, I seem to remember that as well. Yeah.
And I've collection as well that they found a rhinovirus on one of the cameras that had been sneezed on by somebody before it was launched into space. Anyway, there we are. By the way, somebody commented this week about the accuracy of lunar landings these days, but these guys managed to put their lunar module down within walking distance of another space ship back in 1969.
Yeah.
So, I mean, it's not such a new thing, is it, really?
Without the computing power we got today.
Yeah, absolutely. I mean, they had 3 computers on board the Apollo missions, 1 in the command module and 2 in the lunar landing module, and they only had 32K of memory.
Exactly.
Yeah.
And the memory was ferrite core memory. Anyway, I'm going to finish off by talking a little bit about digital art, and I'm just going to stick to one thing, TerraGen. The reason I mentioned TerraGen is that actually you can download a sort of atrophied version of it, if you like, to play around with yourself. So if anybody's noted the name, go and look it up, and you can download a version of the program and try making some of the landscapes that it's possible to make with TerraGen. Now,
I use TerraGen.
Yeah, it's good, isn't it?
Great fun to play around with. Yeah, I used to use. Did you ever use Vista Pro?
No, I haven't. No, is that
it
good?
was sort of the low res precursor to TerraGen, different company. And I used to spend hours creating landscapes, but you can then animate and fly through them, and it was enormous fun.
Well, what you're seeing in these pictures that are following are in fact pictures that are made using Terragen to produce the landscapes, if you like, and then obviously a bit of illustration work added to them to produce the sort of sky and space parts. Well, I said not the sky. Actually, the sky can produce with Terragen too. But you get the idea in this picture here, and we've got a sort of Saturn-like planet with an Earth-type moon orbiting around it. And in this picture here, we can see a planet which is very volcanically active, and obviously lightning strikes due to the dust created in the volcanic eruptions. And in this picture here, I feel this actually illustrates what Terragen does most, actually. It's quite possible to produce almost everything in that picture just using Terragen alone. It does amazing skies and amazing landscapes as well.
It is actually used in the motion picture industry to generate landscapes.
Yes, and of course it is used, as you rightly say, for backgrounds in movies. The full-throated version can. Obviously, the simplified version I played around with doesn't do stuff quite as good as this, but no. you can do a remarkable number of things. You can change the angle of the sun, change the type of clouds, change whether the water is choppy or still. You can do all these things by pressing buttons and mucking around with it. It's really quite fun. So this sort of fanciful dirigible flying over this fanciful landscape is all inside a computer, basically. Here's another one. And by the way, this illustrates where space artists can get a bit carried away. There is absolutely no way that a planet would be as tranquil as the one in the foreground if it was that close to that gigantic planet in the background. The tidal forces would be ripping everything to pieces, and it would be hell to live
like Io.
Like Io, exactly. So there you go. But anyway, it's kind of fun. And we're nearly there. There we go. That's the last one I'm going to show you tonight. The Terragen desert landscape, and obviously a spiral galaxy above it. As I say, it's incomplete. It's just a few things just thrown about, but I hope you've enjoyed having a look at them. Okay, thanks.
Right, thank you very much, Keith. Most